Hello everyone, welcome to the part 2 of the batching series. In the previous video, we explored on LangChain's llm.batch module, using which we batched multiple LM requests together and drastically reduced the overall time taken for classifying Wikipedia articles. Today, we are going to explore on yet another technique, using which we not only reduce the overall time taken for classification, but also reduce the cost incurred on sending these requests to LLM. Let's get started. Before we perform the implementation, let's have a quick recap of what are the things that we have done so far. In experiment number 1, we tried to process the articles in a sequential manner. For example, if we have 3 articles, each article is appended with a system prompt. System prompt is basically a set of instructions that we send it to LLM for classifying these articles. And the major drawback of this experiment is that the articles are processed sequentially, and hence each article has to wait for the response of the previous article. And to fix this, we move to the experiment number 2, which is a batching solution. In this batching solution, we are going to pass all 3 articles at once. Remember, we are sending 3 requests, but all 3 requests are processed concurrently, and hence it shortens the overall time taken for processing these articles. This approach is much efficient than the sequential solution, but there is one more thing that we can do better. If you look at the request, each request is independent and each request has a system prompt and an article. And the system prompt doesn't change across articles, it's going to remain the same. Only the article content is changing across the different requests. What if we can group these requests together with a single system prompt? Yes, that's what we are going to do it today. In today's video, we are going to have a single system prompt, but we are going to batch multiple article contents together. Let's see how it is done. Let's initialize the dataset. And once we have initialized the dataset and done the basic pre-processing as before, and we have 10,000 articles, let's go ahead and initialize our LLM. Okay, the LLM is initialized, and we are using GPT 3.5 Turbo. Now comes the classification prompt. When we analyze this prompt, we have a system prompt, which is the set of instructions, and a user prompt, which is the article content. To group this system prompt and multiple user prompts, let's write a simple prompt here. Say we have list of chat prompt template, and inside this we have a system prompt, which is an instruction, and we have a human prompt. Say it is article 1 content. So this is the setup that we have right now. And what we want to do, we want to classify multiple articles with the same system prompt. Is it possible to copy this? Let's paste a few more times. Okay. Now we have one system prompt, and we are trying to send 3 human messages with 3 different article contents. Ideally, we want to classify these 3 articles in one among these 50 categories and return the result in a JSON format. If we try to send the input in this format, we will be receiving the output only for the latest article content. In a sense, when we group multiple articles as independent user prompts, OpenAI always considers the latest one. Then how can we achieve grouping? The answer is to use the JSON formatting. Remember, when we try to send the input, we are always sending the ID and the article's content in 2 different tags. Instead of sending just one article, what if we can send multiple articles? Basically take a Python list which contains both ID and the article content, and then we convert it to JSON and pass it as a single input. Then the prompt becomes a list of dictionaries where each dictionary will have ID and the article content. Something like this, right? Let's try to do that. First, we will update the prompts. So we have to provide an instruction. Remember, now we are going to send in a list of dictionaries. So you will be provided with a JSON input which contains ID and article content, right? And your task is to perform classification. This remains the same, and categories remains the same. But then when we want to generate the output, it should be a list, because we are going to pass in multiple articles, and hence it should be like this. And maybe we can add ID of the article 1 and category of the article 1, and let's copy paste this, ID of the article 2 and category of the article 2, and so on, right? So depending on the batch size, we need to have a list of dictionaries, each containing the ID and the category, right? Now when we are sending the input, we are going to batch the multiple articles into a single input as a JSON. Let's do that in the next step. Okay, we will bind the prompt and the LLM as a single chain. Now let's perform the sample inference. To perform a sample inference, we are going to pass in a list of dictionaries. To do that, let's say we have a list, and inside this list, we are going to have the ID and the article content of article 0 and ID and article content of article 1. Say article 1, and all we have to do is to convert this in JSON format, right? And this is going to be our content. Let's assign it to content variable. Now let's print the content and see. Now we can see we have a JSON, which is basically a list of dictionaries, and each dictionary contains an ID and the article content, right? When we perform chain.invoke, now we are passing multiple articles at once. Let's try to do that for first 2 articles. Okay, here is the answer. Let's try to load it in JSON format. Loads of response.content. Here you go. Now we can see we try to pass in 2 articles with the same system prompt, but these 2 articles are binded together in a JSON format. And the response from LLM, once we do JSON.loads, we are getting a list of response where each response contains the ID and the respective category. Now let's go ahead and do this for the remaining articles. This is the sequential execution, which took 1 minute and 14 seconds for the for classifying 100 articles. Let's try to do it with grouping. We need a results variable where we are going to store our results, and we are going to set the batch size, say, to 4 now. Maybe we can increase it later. And we need a list because we are going to append multiple user prompts. So for index comma article in enumerate of articles, and I'm going to say keep it to 10 now. Once it works, we can move it to 100. Okay, now whenever I take an article, I'm just going to append this article into input. So inputs.append. So the information that we are going to append is the ID and the article content. Okay, so we are appending the ID and article content. When the length of this inputs reaches the batch size, we need to process it. Remember, we are grouping our requests here, and hence to process this request, we have to perform chain.invoke of, we have to pass in inputs. Right now inputs is list of dictionaries, and hence we have to do json.dumps of inputs. Now by doing json.dumps of inputs, we are sending in a single JSON string which contains 4 articles, right? And hence we can store this response in a variable. Now, after receiving the response, let's append this response to the, we can do response.content and append it to the response results list. And we have to reset this list so that we don't process the same input again. And we also have to see if there are any leftovers. We have to do if of inputs. If there are any inputs remaining, we just do response equal to chain.invoke of this. Okay, now let's try to run this code. Let's see if we are getting successful results. Okay, it's done for 10. Let's try to see what is there inside results of 0. As we can see, results of 0 contains a JSON which has the results for 4 different articles. Here we see ID with 12 and it's set to politics, and ID 39 set to science, and so on and so forth. Right? Now let's go ahead and change this to say 8, right? And let's try to process 100 articles. Since it's just 100 articles, I'm not adding a delay. But if we are trying to pass in 1000 articles, then make sure we add a little bit of delay so that we don't send more number of tokens into LLM, because LLM comes with a rate limit. Let's go ahead and run it. Now we have the result. It took 27 seconds to process these 100 articles, and whereas in the sequential execution it took 1 minute and 14 seconds. The main difference between this approach and the previous approach, which is experiment number 2, where we tried to batch using chain.batch, is that in chain.batch we have been passing the system prompt again and again. Imagine this system prompt is say, now we have just 3 lines. Imagine this is having a longer instruction with 1000 tokens. Then for, if you set your batch size as 8, then you're sending 8000 tokens just for the system prompt, right? And in this approach, we are just going to send only once, and hence we are going to get billed for only 1000 tokens. With this implementation, there are 2 important things that we need to keep it in mind. One is the context window. Since we are grouping multiple articles together into a single JSON, we are sending too many tokens in a single request. When we are appending multiple articles, say when you are setting batch sizes 8 or 16, we are going to append 16 different article contents into a single prompt, and hence we need to make sure the request that we are sending into LLM does not exceed the overall context window. Another important point to note is the rate limits. We have 2 important rate limits. One is the request per minute, the total number of requests that we send in within a minute, and the tokens per minute. With respect to RPM, it's the current approach is not like LM.batch, because in LM.batch, when you set the batch size as 8, we'll be sending 8 different requests in a concurrent fashion. Here, the requests per minute will be drastically reduced because we are going to combine all these 8 articles content into a single JSON, and hence we are sending only 1 request instead of 8. But at the same time, we are collating all these 8 articles content to a single prompt and sending it to LLM, and hence the tokens per minute will be high. Let's quickly write the post-processing code. Say for each result, right, the results, we have, say, let's write a list comprehension x dot response metadata, right? And for each response metadata, I need to fetch token usage, and let's convert this to a data frame. Okay. Now, if you look at this data frame contains the completion tokens, which is output tokens, the prompt tokens, which is the input tokens, and the total tokens. Let's take the total tokens and find the sum. Okay. Overall, for processing 100 articles, we have consumed 17,511 tokens, and it took around 30 seconds to process 100 articles. The same batching, when we did it with chain.batch, it took 17 seconds, but here you can see the total number of tokens which is consumed is almost 38,337. With this result, it's evident that the approach of grouping multiple articles into a same system prompt is not only faster, it almost consumes only 50% of the overall tokens. I hope you find this information useful. If so, hit the like button and subscribe to the channel. Thank you.